Alright, what's up everybody? So we are in our final round for surface area. We're getting into pyramids. So let's crank this out. Should be pretty quick. So we all know what a pyramid looks like, but a geometric definition is a 3D figure with one base in the shape of a polygon and multiple faces that meet at one point. Looking like this guy right here. Now, for us, all the pyramids that we're going to look at the bases are all going to be regular, meaning all the side lengths will be the same. And for the most part, we'll be sticking with square pyramids, all right? Also, pyramids get named just like prisms by the shape of their base. So you could have a triangular prism, a quadrilateral prism, like a rectangular prism, an octagonal, I keep saying prism, octagonal pyramid, a square pyramid. You could have a pentagonal pyramid, right? But we're mainly going to be focusing on prisms that have a base of a square. Okay. Let's look at the net next. So when you look at this net, notice that all the lateral faces are triangles, right? And so that's going to be really important to understanding the surface area formula. So what I'm going to do is I'm going to lay this out. And so notice that when I put them all side by side, this distance in orange right here is actually the perimeter of our base. So that's important to know. And also important to know is that all of those triangles have the exact same height, okay? As in, this distance is all the same because all those triangles are the exact same size. Okay, so for our formula, we're going to have base area, our capital B as usual. We're going to have perimeter, so I said perimeter of the base, and the reason that why is because of this guy right here, right? And then finally, we're going to have our slant height. Now remember, slant height is the distance from the edge of your figure to the top, and the slant height of the face is actually the height of all of these triangles. Okay, so normally, right, when we do the surface area formula, it's into two categories. You have your area of your base or bases and the area of your lateral faces. And so technically, these right here, we can use one big formula to find all of them because we have that orange base, which is again the perimeter here, and they all have the same height. So our formula then is going to be area of the base plus 1/2 times the perimeter of the base times the slant height. And this is strictly being stolen from an area of a triangle, 1/2 base times height, right? This is supposed to be an A, area of a triangle. And the base, again, is the perimeter, and the height is our slant height. Because remember, if I were to look at my net, this is where our slant height is, right? And then all those triangles, their base is the perimeter added up. And so that's why we can divide this up into two little sections and make it easier and not have to find the area of one triangle and then multiply it by 4. I mean, you could do it that way. It'd still be correct, but I think this other way is faster. So let's jump into some examples, okay? So for this first one, I made it pretty simple. I gave you the slant height, and then I also have given you the side length of one side. Remember, this is regular, so that means that this is 7 as well. So our base area is just 7 times 7, base times width, or height times width of a square, however you want to look at it, so 49. Our slant height given to us is 11. And the perimeter of our base would just be 7 times the number of sides we have, which is 4, so that would be 28. So all we have to do now is plug those values into our formula. Area of the base plus 1/2 times the perimeter of the base times our slant height. 1/2 times 28 is 14. 14 times 11 is 154. So 154 plus 49 is 203 feet squared. So the surface area of that pyramid with those dimensions is 203 feet squared. Let's make one a little more challenging. Okay? So within this second diagram, I've given you the length or the height of the pyramid, right? So the distance from the top vertex down to the center of your base is called the height. And again, we'll use height for pyramids and for cones when we start getting into volume, all right? But we don't technically use it in our formula. However, we're going to use it to find our slant height and to find our radius. So the distance from the center to the edge is the radius of our base, okay? And notice that the slant height, the radius, and then the height of the pyramid are making a right triangle, and the angle of elevation that they're giving us is a 60 degrees. So we'll need to find our slant height and our radius right here. So let's go ahead and pull out that orange triangle. Let's write in what we know. So I know I'm trying to find my slant height. I'm trying to find the radius. I know this angle is 60. I know this is 6. And hopefully we recognize this is a 30, 60, 90. You could also use trig if you want to use trig. There's no problem with that. Just a reminder what our 30, 60, 90 ratios are. We know this is x, this is 2x, and this is x rad 3. So since I know that x rad 3 is 6, I'm going to have to take that 6 and divide it by radical 3 to get the radius. So this amount is 3.5. Okay? So because that's 3.5, that means my entire side length is double that, because that distance is halfway across. Just like a radius is half a diameter of a circle, if the radius of a regular polygon is halfway across, so this would be 7. The slant height is double whatever that 60 leg is, so 3.5. So that's also 7. So we know our slant height is 7. We know that the perimeter of our base is, again, because this is regular, 7 times 4, so 28. And the area of our base is 7 times 7, which is 49. I did not mean to make these have the same base dimensions, but it just happened. It's okay. So now our surface area equals area of our base plus 1/2 perimeter of the base times my slant height. Again, 1/2 times 28 is 14. 14 times 7 is 98. So we have 98 plus 49. That gets us 147 inches squared of surface area. All right. Let's do one more, then this video will be done. So for this one, I gave you the height again, and now I'm giving you the side length of one of the bases. And remember, these are all the same length. So first things first, we know our perimeter is going to be 8 times 4, so 32. Our area of our base is going to be 8 times 8, which is 64. And the one thing we have to do now, though, is we need to find our slant height. And to do that, I'm going to draw in a radius. I'm going to draw in a slant height. So you actually need to remember that the distance from the center to the edge of the base is half a side length. So that means that that side length right there is 4. So our slant height is going to be the result of Pythagorean theorem of 9 squared plus 4 squared equals L squared. So 81 plus 16, because again, guys, the reason why is because we have a right triangle right here. Remember, the slant height combined with the radius combined with the height of the pyramid is making a right triangle. So we get 81 plus 16 equals L squared. 81 plus 16 is 97. So 97 equals L squared. Take the square root of 97, and that gets us 9.8. So our slant height is 9.8. Once we know that it's 9.8, we can use our formula. So surface area equals area of our base plus 1/2 times the perimeter times my slant height. 1/2 times 32 is 16. 16 times 9.8 is 156.8. So 64 plus 156.8 is 220.8 meters squared. And that's it. All done with surface area. Good luck. Let me know if you have any questions.